Hi friends, today we are going to talk about a fascinating topic in physics, the pendulum. You may have seen a pendulum in a clock or in science experiments, swinging back and forth in a smooth, rhythmic motion. But have you ever wondered about the energy transformations happening during its motion? Let's break it down and understand how energy flows in a pendulum system. A simple pendulum consists of a mass, called a bob, attached to a fixed point by a string or rod. When you pull the bob to one side and release it, it swings back and forth due to gravity. This motion is a perfect example of the conservation of energy. Now, let's talk about total energy. The pendulum's total mechanical energy remains constant if we ignore air resistance and friction. This total energy is the sum of two types, potential energy Pe and kinetic energy K. These two energies keep converting into each other as the pendulum swings. Potential energy is stored energy due to height. When the pendulum is at its highest point, it has maximum potential energy. This is because the bob is farthest from its resting position and has the most height relative to the lowest point. The formula for gravitational potential energy is P equals mgh, where m is mass, g is gravity, and h is height. Since h is maximum at the peak, Pe is maximum there. Kinetic energy is the energy of motion. It depends on the speed of the bob. The formula for kinetic energy is K equals 1/2 mv squared, where m is mass and v is velocity. When the pendulum reaches its lowest point in the swing, its velocity is highest, meaning kinetic energy is at its maximum. Let's summarize how energy changes throughout the swing. At the highest point, the pendulum momentarily stops before swinging back. Here, velocity is zero, so kinetic energy is zero. However, since the bob is at its highest point, potential energy is at its maximum. As the bob starts moving downward, potential energy starts converting into kinetic energy. The pendulum gains speed, and kinetic energy increases while potential energy decreases. At the lowest point, the pendulum is moving at its highest speed. Kinetic energy is at its maximum, and potential energy is at its minimum because the height is the lowest. As the pendulum moves upward, kinetic energy starts converting back into potential energy. The bob slows down as it rises. At the opposite highest point, the motion stops again for a brief moment before swinging back. Here, kinetic energy is again zero, and potential energy is maximum. If we were to plot a graph of these energy transformations, we would see that the total energy remains constant throughout the motion. The kinetic energy curve peaks at the lowest point, while the potential energy curve peaks at the highest points. The sum of these two curves at any point in time equals the total energy, which remains unchanged. But in reality, air resistance and friction at the pivot slowly reduce the total energy over time. This causes the pendulum to eventually stop. However, if energy is continuously supplied, like in a clock, the pendulum can keep swinging indefinitely. So, the next time you see a pendulum, remember the invisible energy transformation happening behind its motion. It's a beautiful demonstration of physics in action. That's it for today's discussion. If you found this interesting, share your thoughts, and stay curious.